Okay, in 11.1, we're going to look at the square root property. So what we're looking at in chapter 11 is different ways to factor or to solve things when they can't be factored. And so when we're solving anything with the exponent higher than 2, we want to try to factor it. And if we can't factor it, then we're going to learn 3 ways today to do that in case we can't. So the first one is the square root property. So when we look at this first problem, in the past, before today, we would have moved our 169 over, I'll just do it up here, and made this z squared minus 169 equals 0. And then we would factor that as the difference of 2 perfect squares. So we'd say that's z minus 13 times z plus 13 equals 0. And then remember, you set each factor equal to 0. So z equals 13, z equals negative 13. Takes a while. But if this wasn't a perfect square like 50, then we couldn't do that, and we would have just wrote that it was prime, that we couldn't factor it. So today we're going to look at the square root property. So because we have z squared on one side and the number on the other, in algebra you can always get rid of things by doing the opposite. And so to get rid of this z squared, the opposite of a square is a square root. So we can just square root both sides and kind of skip all those steps. So the step of the square root of z squared is just a z, and the square root of 169 is 13. But you see, when you square a perfect square here, you're going to get a positive and a negative. So anytime you use the square root of property, you have to write plus or minus there. So z is going to equal to a positive 13 and a negative 13. So this next one, m squared equals 36 over 11. We just square root both of them. So m would equal, remember you got to put a plus or minus. The square root of 36 is a regular 6, but we don't know the square root of 11. So that's a plus or minus 6 over the square root of 11. But you can never leave a square root on the bottom. Remember, it's not in standard form with a square root on the bottom. So for this one, we've got to rationalize the denominator by multiplying the top and the bottom by the square root of 11. So we talked about that in 10.5 and 10.7 actually. So our final answer is plus or minus 6 square roots of 11 over 11, because the square root of 11 times the square root of 11 is a regular 11. So this next one is one we could not have factored because 50 is not a perfect square, but by the square root property we can move the 50 over and say p squared equals 50. Then we can square root both sides and say p equals plus or minus the square root of 50. Remember, you got to do the plus or minus. And now this is not in simplest form because 50 would break up to be the square root of 25 times the square root of 2. So your final answer is p equals plus or minus 5 square roots of 2. And that's your final answer. Okay, but you notice before we take the square root, we have to have the squared on one side and all the other numbers on the other side. So before I can solve this one, I have to move the 3 over by dividing it by 3. So I get p squared equals 10/3. And then I can square root it and get p equals plus or minus the square root of 10 over 3. But remember, you can't leave it in that form because this is really p equals plus or minus the square root of 10 over the square root of 3. So we have to rationalize that denominator. And so our final answer would be plus or minus the square root of 30 over a regular 3. And you could try to simplify the square root of 30, but it won't simplify. And remember, you can't divide a square root with a whole number. You can only do square root by square root, whole number by whole number. But these next ones are where the square root property comes into a really helpful thing, because think about it, in the past we would have had to multiply this out, moved our 16 over, factored it back, set each factor equal to 0. As you know, it was about an 8-step issue there. But now that we have a squared on one side and a number on the other, I can just square root both sides. So the square root of x minus 7 squared is just an x minus 7. And the square root of 16 is 4, but just remember you have to have a plus or a minus 4. So you don't have to split it. So I'm going to show you the long way, but then I'm going to show you how to do it in your head. So really what you've got is x minus 7 is equal to a positive 4, and x minus 7 is equal to a -4. So you really have to solve both of these. So here I would add 7 and get x equals 11. Here I would add 7 and get x equals 3. So you're going to have two answers. So you can either split it up like this, or if you're good with your sign rules in your head, you can just think, okay, I'm adding 7, so I have a +4 plus 7 is 11, and a -4 plus 7 is 3. So if you can do that in your head, it's perfectly okay to do it that way. This next one, same thing, we're going to square root both sides. So I'm left with p minus 5 equals plus or minus the square root of 40. But 40 is not in simplest form, so we want to simplify this if we can. So this would be a plus or minus, 40 would break up to square root of 4 times square root of 10, or 2 square roots of 10. So I have p minus 5 equals 2 square roots of 10. But now to get p by itself, do you see you have to add a 5 to both sides? And you can't add a 5 and a radical there. So this is just going to be 5 plus or minus 2 square roots of 10. So the shortcut I want you to see here is you can just take this -5 and move it to the other side and make it positive. You really don't have to show these steps right here. So just move that over and make it a 5 plus or minus 2 square roots of 10. Let's look at this next one. Again, we're going to just square root both sides. So I get 5t plus 3 equals plus or minus 6, because the square root of 36 is 6. And again, if you can do this in your head, you definitely can, but let's split it up and show the actual steps. So you get 5t plus 3 is equal to +6, and 5t plus 3 is equal to -6. So do you see here, we would minus our 3 and get 5t equals 3, and then we would divide by 5 and get t equals 3/5. So there's that one. Here I'd minus a 3 and get 5t equals -9. Divide by 5, t equals a -9/5. So there's our two answers. Okay, so if this is a whole number, I do think it's easier to just kind of split it up and work out the two problems. But let me show you a shortcut kind of on this one. So here we're going to square root both sides and get 5z plus 6 is equal to plus or minus the square root of 75. That's not a perfect square, but we can simplify it by saying 75 is the square root of 25 times 3, or plus or minus 5 square roots of 3. And so we've got our equals, and we've got all this over here, so you could bring it down and solve it. But you see, just like we did here on both sides, first we subtracted 3, and then we divided by 5. So the shortcut for this is, well, let me just go ahead and rewrite it. Is when you're getting your answer is going to be z equals, do you see you're going to minus a 6, and then you've got that plus or minus 5 square roots of 3, and then you're going to divide everything by 5. So if you need to split it up into 2, you definitely can, but just remember this comes over and changes signs as a -6, and to get z by itself, you would divide by 5. And so that's kind of a shortcut to get your answer. So that's 11.1, or the square root property. So you're ready to try the practice problems on 11.1.